there, welcome to my video tutorial about sparse matrix. Have fun and enjoy listening.
Hello, good day. So our lesson topic to be tackled now is about sparse matrix representation. So first, we have to define what is sparse matrix. So when we call sparse matrix, it is having the majority of the elements equal to 0. Therefore, whatever the matrix have, the majority elements will see 0. Or let's say, it is a matrix that has a greater number of 0 elements than the non-zero elements. This is for using also two-dimensional array. And instead of storing zeros elements, only we store non-zero elements. This is the focus here in sparse matrix. So I have here the table. This table contains of 6 by 8 or size of 6 rows and 8 columns. So we have here in storing non-zero element with row, column, and values. The one here. So I just went out. Okay. Then sparse will going to make another table. This will have the output we need in our code after this. Then in here, I have used an array representation that is two-dimensional array. Sparse matrix values size here is 6 by 8. 6 for the row and 8 for the columns. So we have 0, 1, 2, 3, 4, 5, 6, 7 for columns and 0s, 1, 2, 3, 4, 5 for rows. And then I have the values here, non-zero elements and the 0 elements. And yes, we used to observe that there's many zeros or unwanted values to be set in our table here. So before we proceed, let me ask you this. Why do we need to use a sparse matrix instead of just a simple matrix? So first, we have this in advantage of in our storage. As we know, a matrix that contains lesser non-zero elements than 0, so less memory can be used to store elements. It evaluates only the non-zero elements. And then lastly, in computing time, in this case of searching sparse matrix, we need to traverse only the non-zero elements, as what I've said earlier, rather than traversing all the sparse matrix elements. It saves computing time by logically designing a data structure traversing non-zero elements. So, lakto na pagka-storya, ihawa niya in sparse matrix, ihawa niya ang mga walay gamit na data katong mga non-zero element ay rather than 0 elements. So we look here in our table. So we have here the following elements: 0, 0, 12, 0, 14, 0, 12, 11, and so on. Then in a row, 0, 80, 0, 0, 23, 0, and so on. And then we have this so-called row major and column major. This will serve us in having these non-zero elements here, or by having these values. But I will going to use hereafter is a row major for having these values in our code to present after this. Then, when we called column major order as a method of representing multi-dimension array and sequential memory, thus elements of first column occupies first set of memory locations reserved for the array. Elements of second column occupies the next set of memory, and so on, or it should be called column major starts from rightmost index. Here, so for example, column 0 to row 1, then the non-zero values is 80. The next, column 0 to row 4, then the non-zero values is 23. And then column 1 to row 3, then the non-zero values or the non-zero elements is 10, and then so on. Then, when we called row major, it is also a method of representing multi-dimension array in sequential memory. In this method, elements of an array are arranged sequentially row by row. Thus, elements of first row occupies first set of memory locations reserved for the array. Elements of second row occupies the next set of memory, and so on. In other words, row major starts from the leftmost index, because if column major start from the rightmost index, then row major starts from leftmost index. Like for example, in this table, this is a kind of row major, example of a row major. Like row 0 here to column 2, then the non-zero elements or the non-zero values is 12 here. The next, row 0 to column 4, then the non-zero elements is 4. This is the value, 14 rather. Then row 0 again to column 6, then the elements non-zero is 20. The next, row 0 still, then into column 7, and it has a non-zero elements is 11, and then so on. Just repeat it and repeat. So otherwise, we will make a column major here in order to understand more, because we have a row major already and we will make a column major here. So column, and this will row. These are the values. So first we have our column 0 here to row 1 and column 0 to 1, and the values here is 80, non-zero values, 80 here. Next, column 0 to row 4, column 0 to row 4, then its value is 14. Then column 1 to 3, column 1 to 3, then its value is 10. This is 14. No, I mean column 0 to row 4 is 23. So 23 here. Then column 1 to row 3 is 10 here. Then column 1 to 4. Then our value here is 27. Then our column 1, next is column 1 to row 5, then it is 46. Next, column 2 to row 0, and it has 12 non-zero element. Next, column 2 again to row 3, and it is 16. Next, here is column 3 to row 4, column 3 to row 4, and it has 41 non-zero value. Next, column 3 again, and it has a row 5, which is 71. Next, column 4 to row 2, column 4 to row 2, no, column 4 to row 0 pa day, 0 here, and it has 14 values. Next, column 4 to row 2, column 4 to row 2 is 87. Next, to column 5 here to row 1, 1 is here, then it has another element of 13. Next is column 5 to row 4. Column 5 to row 4, and it has 22. Next, column 5 to column 5 is 64. Column 5 to column 5 is 64. No, this is first. Column 5 to column 5 is 64. Here. Next, column 6 to column 0. The values is 20. So next is column 6 to row 1, and it has 63. Next is column 6 again to row 2. It has 31 non-zero value. Then the last row and column, so column 7 here to 0, row, column 7 then 0, then it has non-zero elements of 11. Lastly, column 7 to row 5, and it has 93 non-zero elements, and that's it. These are column major now, and this is a row major now. Still, our non-zero elements here, the number of non-zero elements is 19. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. Same as in row major. So now let's proceed to our code to execute these tables and to have the value of another sparse matrix table. Okay, let's start. So now here in our program, I have already made the whole program, the codes for executing. So I will discuss to you this. So this program will accept the sparse matrix and will print the triple representation. Triple representation is the row, column, and values. The other sparse matrix table to have the values of the non-zero elements. Okay, we have this include, then end main, and we have also this end. Our array is our main array, 6 for the row and 8 for the column, and we have R for row, C stands for column, then we have an I variable which is used in our first loop, and J variable, the second variable which is used in our second loop. And we have here the values is equal to 0. It has called to be values or the non-zero, and we have the triplet, and I use it trip. Then maximum number of row is 50. Then maximum number of row is 3 because it only have 3, the row, column, or the values or the non-zeros, or it has to be column, row, or the values or the non-zero zeros. Here this another table. This is the use of this. Then we have our temp is equal to 1. So first this is to display the program of a matrix for the user to sparse matrix. First, we'll print the total number of rows of the matrix, and we will use scanf for %d because here we are accepting the rows, and then we also print and will enter the total number of columns of the matrix, and we use scanf %d to scan the value of columns, or this accepting the columns. Then in here it will input the sparse matrix or value of sparse matrix. So we have 4 of I is equal to 0, I is less than R, or we used to call the row, then I plus I, or I increments. And this is our first loop that will accept the rows values. Then our second loop that accept the columns is for of j is equal to 0, j less than column, then j plus plus. Then after that, it will print the value of the sparse matrix. It will also we will also use the scanf for inputting the matrix. And then in this code, we were executing or to display the sparse matrix. First, we will print the values of sparse matrix one by one. Then these are the first loop and the second loop, accepting the row and the column. Then we will print this. Then we will also print fn. This use is to go to the other line. Then here to determine in this code, this will to determine or to count the total number of non-zeros. To execute this following, to execute those, you have entered the non-zero and zero elements, or the column elements and the row elements. So again, this is our first loop and the second loop for accepting the rows and the column. Then here, if the elements become non-zero, it will be here. If the loop will going to become a non-zero, it will be here. If of array ij, then we have these values plus or because what we call this, we use this values plus or increment because we need to increment the values or the non-zero elements. Then in this code, we have to convert the following table into triplet matrix. The sparse matrix will going to convert into triple matrix, which is what I've said earlier. This row column value, this will going to execute in this code. So we have our triple or trip main trip, and then it is the total number of row, then here the total number of column, then the total number of values or the non-zero elements or the values. Then here to check if which value is a non-zero, from 0th row to the last or 0th column to the last. So we have this triple of temp 0 is equal to I for row, then triple of temp 1 is equal to J for column, then triple of temp 2 is equal to array I and J, and we have this temp plus plus because we need to increment the temp variable as usual. Then lastly is for executing or to display the triple matrix. And it will print the row column value. Row here first and the column here is the second, because as what I have said earlier, what I have used a major is a row major. So we have the first increment or first loop rather to accept the row. 4 of I is equal to 0, then I is less than 6, then I plus plus. Then the second loop is for A, 4 of J is equal to 0, J is less than 8, then J plus plus. And we have the values array I, J, then it will print the following. This for the row, this for the column, and this for the values. And that's all. So we will run this program. If yes, I know it will run successfully. Okay, so this will ask to enter the total number of rows. So our total number of our rows here is 6. This 6 because it is 6 by 8, so we have to enter this 6. Then please enter the total number of columns of the matrix. So we have 8. Then we have to enter the value of sparse matrix. These are the following. We need to enter all of this non-zero and zero elements. So we have to enter the value of sparse matrix. These the following. So in here we will use the row major in order to get the value of sparse matrix, that this triple matrix, this. Okay, so we have here 0, 0, 12, 0, 14, 0, 20, 11, 80, 0, 0, 0, 0, 13, 63, 0, 0, 0, 0, 0, 87, 0, 31, 0, 0, 10, 16, 41, 0, 0, 0, 0 again, 23, 27, 0, 0, 0, 22, 0, 0, 0, 46, 0, 71, 0, 64, 0, and 93. Then to enter this, and these are the values of sparse matrix. This is correct. Okay, then this is our triple matrix. Another table. And we will check if this is correct here. So row 2, this is a row major, so we have 0, 2, 0, 2. Okay, then the values, the 14, 20, 11, 13, 63, 731. Okay, so it is correct. And that's all. I hope you have learned something in this tutorial, in this discussion. So this is the end of our discussion here. Thank you and God bless. See you in my next tutorial. So in my short reflection, the title in this topic is about sparse matrix. Again, when we say sparse matrix, it is having the majority of the elements equal to 0. This will have to say that whatever the matrix will have, the majority of the elements will see is 0. Or let's say it is a matrix that has a greater number of 0 elements than non-zero elements. In this sparse matrix, I've learned a lot. Before I had done this tutorial, it was very confusing on how to get those sparse matrix value in a code. Those triplets matrix, how that something will make into another table of sparse matrix, so on. And mostly how I will be able to start this lesson tutorial with my mind clearly gets the idea of this program should make. But in the end, it will be worth it to know that I had done enough to this activity, because I gave all my best to perform and explain the program I made with the love of what I am doing. So that's all. Thank you for listening and keep to the end of this video tutorial. I hope you have learned something about sparse matrix. Thank you and God bless.